Okay, so and as for the rules, as for the basic rules, in the final exam, I have tell you in the uh, last class. And if you have any questions, you can send message to me. Also, you can watch my YouTube channel. You can watch the record of class before. And today we are going to do a review also. And today's content is also very important about the topographic drawings. So let me share the screen. Okay. Oh no, I know. Okay. I will share the PowerPoint with you. And today we are going to do a reviews about the slope and what is the slope and how to draw the section line, the intersection line between two surface, and between the surface and the ground, so that you can draw a ground line that surround with a dig. So at first, let me see. Okay. From this page. I know that some of you have learned very well, and as for others, and I think it is not. It's not. So let me see. Here is the point on the topographic drawings. It's a basic knowledge about how to draw the slope and the oblique line in a three-dimensional space. So at first, so you have to know what is the elevation. So if there is a plane, there is a plane that the elevation is zero. Is a basic plane, and so you can see the the elevation is a. It means that the distance between A to the plane is 5 meters. The vertical distance. So that is the elevation of A, and how to represent the point A in the top view. You can see the right side. You can use the A5. It means that this point A with the elevation of 5 meters. Also, you can see the C with the elevation of 0. It means that the C is just on the ground plane, on the ground. Also, you can see the B point is the -3. The elevation is -3. It means this point is below the ground, not above. A is above the ground. Of course, you can see the scale ruler. So you must know how to use the scale ruler to measure the horizontal distance between these points. Okay, so that is the elevation of the point, and the next one is the line. It's obvious that when we connect 2 points, we can get a line in three-dimensional space. Is also. So we can connect the point A and point B with a line, with a line that is blue color, you can see this. So the line A and B, the line A and B is not parallel to the ground. It's not parallel to the ground. So it is a oblique line. It is an oblique line in space. And so you can see the difference between A and B. The difference between A and B. So if I watch this line from this wheel, you can see the arrow height direction. Maybe the shape is like this. Like this. Okay, so this line means the 0 meters, 0 meter elevation, 0 meter, and this one is A3, and this one is B4. So now you can see the difference of the elevation between these 2 points. Yeah, so it's easy for you to calculate. Its the difference is 4 minus 3. Okay, is equal to 1 meter. 1 meter. And so now we have learned where we have get the difference between the between 2 points. And so how can we get the horizontal distance? This one. So if I get the horizontal distance, and we also the difference between the LV 2 points of the elevation is given, and so that we can get the slope. Maybe you have remember I is equal to L divided by H. No. Sorry, I make the mistake. H divided by L. H is a difference. In the elevation between 2 points, and L is the horizontal distance of the projection. The projection of these 2 points. So the next procedure is to use the scale ruler to measure the projection of this line. So maybe so now I can't move it. And I can't use a ruler in this screen. So I guess it is almost 5. It's almost 5. And h is equal to 1. So how about slope of this line AB? Is equal to 1 to 5. Usually we represent the I use this way. So you can see that is the slope. That is the slope of this line. So now please think about. I'll give you several minutes to think about. How about the slope of this line CD? How about the slope of this one? How about the slope of this one? So who can tell me? So I gave you 3 minutes to think about this question.
The slope of which one?
So it's 0?
The slope of which line?
Oh, this one. This one, CD, the slope of CD.
Okay.
Okay, so you can see how to calculate the slope of this line CD. Oh, okay, it's 0? Yes, so how about the others?
Yes.
Yes, of course, and it's great. You can see the CD, CD, okay, it's equals to the difference of the elevation is 3 minus 3 and divided by L. So what L the L is so the the difference of elevation is 0 is 0. So the slope I is 0. Zero. So it means that the line, the I is 0. It means this line is parallel to the ground. Its line is parallel to the ground. So it's very easy to understand. So I will. I'm drawing the. The another wheel. Another wheel. And this one is D3. And here is the ground, and and you can see this elevation. This elevation is 3, and this one is 3. So it must this line must parallel to the ground. Must parallel to the ground. Okay, so I think the slope, the concept of slope is very easy, very easy. So if you forget, you can remember this this formula. This formula. You can remember the difference. The difference of every region is above, and the error, the horizontal distance is below, and use this divided by this one. Now you can get the I. You can get I. Okay, so you can see. Okay, so you can see that is the I. Okay. And now we know the line, we know the slope of a line. So how about a slope of a plane? How about a slope of a plane, of a given plane? So you can see, as for plane, as for this plane, you can see there are many contour lines with a different elevation, and they are parallel to each other. They are parallel to each others. Because this is a plane and not a circular plane. Is a plate. Is a plate, and so you can see many contour lines are parallel to the to each other, and the slope of this surface this plane is the line, is the slope of the line that vertical to all the contour lines. This one, you can see. This one is this one. This line slope is means that the slope of the line of the plane so that you can see we can represent plane a plane in a 3D space. Use a contour line, and a slope line that vertical to the to a given contour line, lines. So that is a way to represent a plane. Okay, so and this one, as for this one, you can see here is a plate. Here is a plate. Let the elevation, the elevation is of the top of this object is 8, and then the bottom, and at the bottom is 0. Is 0. This one is 8. This one is 0. And so as for this one, this one is the is a plane. Is a plane, and you can see the 8765 is the contour line. Is the contour line of this. With this elevation, it's not 0. It's not 0. It's 4. It's 4. Okay, so now how to calculate the slope of this plane? How to calculate the slope of this plane? So you can see the I equals to h divided by L, and the distance difference of elevation is 4, and the L is 1, 2, 3, 4, 4 multiplied 2 is 8. 8. So it's equal to 1, 2, 2, 1, 2, 2. So we can use the given elevation and the given horizontal distance and calculate I. But if we don't know the difference of elevation, it's not known. If it is not given, you can see it's I don't know. But we know the distance, horizontal distance L, and we can and the I is given, and the I slope is given is 1, 2, 2. So can we calculate this one? Of course, it is 8 multiply 1, 2, 2 is equal to 4. Equals to 4, and you can see this elevation at top is 8, and the bottom is 8 minus 4 is equals to 4. So we can use the slope of this plane and calculate and the distance of the horizontal distance, and we can calculate ground elevation. We can calculate ground elevation. So usually, if we are digging deep, so we can calculate the horizontal distance. We can get the horizontal distance, and we can, if we are horizontal distance is given, slope is given, we can get the difference of the elevation. And so there must be a question about this in the final exam. So there must be one or two questions. Okay, so you can see now we can represent a plane by a contour line and a slope line that vertical to this contour line. So how about the relationship between two plane, between two plane, because the object of in the engineering has not only one plane. There are many different planes. Even the circular planes combined together, it will shape complex buildings, complex dam, or the road, and many other constructions. So. Oh, okay. Is Okay, so there is only two relative positions between two planes. The one is the two planes parallel to each other. The two planes parallel to each other. And the next one is the intersection of the two plane. Intersection of the two plane. So if the two planes are parallel to each other, they will never cross, and they will never have the intersection line. So it is not common in engineering, and the most common situation is the intersection of two planes, and so we have to get the cross line, intersection line of the two planes. Okay, so now I will repeat how to get the intersection of two planes. So you can see, as for two planes, the intersection of these two planes is a line. But as for a plane and a circular plane, it's not a line. It's a curve. And you can see the point A and the point B must on this cross line. Okay. Oh, there's something wrong with my internet connection. Okay, it's going better. Okay, so you can see point A and point B, point A and point B. So now you can understand the point A and point B is both on the intersection line. So we can if we get these two points and we connect this point, and this line must be the intersection line of these two planes. So where is A and where is B? So A, you can see we use a horizontal cutting plane to cut these two planes, and we can get two contour lines. We can get two contour lines, and it must cross at A, and it will cross. It will cross at A, and also we use another horizontal cutting plane and cut the P and Q to cut P and Q. We can also get another two contour lines that the elevation is the same with the cutting plane. Also the H9 and the H6, and then we prolong the contour line, and because it is not parallel, it must have a cross section A and B. So we can connect A and B. We can connect A and B, and it is this line is the cross section line of these two planes P and Q. Okay, so so you can see it's an example. And I think all of you have do this exercise. So please think about it. So how can we get the two intersection or how can we get the intersection line of two planes? So you can see this one, the red line, and the red line with the elevation is 25, and the slope is 1 to 2. And as for this one, we represent this plane with two parallel contour lines, which the elevation is 30 and 12 and 15 respectively. So this line and this slope represent plane, and this one, these two parallel control lines also represent another plane. So how to find the intersection line? So at first, we have to get the cross point at the same of two control lines at the same plane, at the same elevation. So you can see we have already known the this line. This line is the elevation 25, and so we must get another line that the elevation is 25 in this plane. And we can get a cross point. And as for the next one, we can get another one, 20. Also, we can get another line with from the slope and the scale ruler. We can get the 20. Also, some students ask me, so if we don't use the 20, we don't use the control line 20, can we use another one? Yes, of course, you can use another one. For example, you can use the 15, the control line with elevation is 15, and also you can use this one. So the key point is you have to use the slope and the scale ruler to find to find the control line you want to get. Okay, so you can see this green one. This green one is the intersection of these two planes. Okay, so now you can see this is a projection. This is a engineering construction about the foundation. So usually this one is known. We know this shape. We know the dimension of this shape. And also we know the slope. The slope of this surface of this plane. And we know the elevation. For example, it is -4. We know the elevation of this plane, and we know the elevation of this one. For example, is 0. So the aim for us is to draw this one so that we can tell the workers where we should dig. Where can we dig? So it's very typical questions about the topographic drawing. Okay, so that is a very old question. So you have to do it. So so please look at this question, and I'll give you maybe 10 minutes or 10 minutes. You can, and so if you finished your drawing exercise, you can send it to me. So okay. So it's just like the final exam. Okay, so please use your hand. And draw it. Use your pencil. Use your paper. Use your hand. Okay, 10 minutes. 10 minutes for you.
Aushi?
Hello?
Yes, Aushi. Which side we will do it?
Well, pardon? Well, I'm not clearly.
All which side we will do it? All sides or one side like this?
Oh, you have to draw the surrounding of this foundation.
Okay, Aushi.
Okay. So you can see draw the digging line and the intersection. So you can see we have to draw this one, this surrounding line. So maybe it is the question in your final exam because it is very typical and it's easy for me to change the elevation. So I will change the elevation of this question and it will be your questions in your final exam. It's very important for you to learn the procedure to draw the intersection line and between the slope and between the ground. So I have to infer that if you don't use your ruler and pencil, so don't send your drawing to me. Please use your ruler and your pencil. For each line, you have to use the ruler. So do you have any problem? If you finished, you can send it to me. I will check it and I will let you know how many scores we will get on this question. Okay, someone finished. Let me see. 6, 6. Yes, 4, 4, and 8. Yes, very good. And Mengjun, you have to label the elevation, the label the elevation on the ground and the bottom of this this foundation. Okay. Okay. How about others? So will you finish? Will you finish? And give you 2 more minutes, and I'll show you the answer. Li Qing, I think your drawing is not good, because I think the 8 and the 6 are in the same size. It is not real. It is not good. I can't distinguish the distance of 8 and 6. And you didn't draw the intersection line. You didn't draw the intersection line. Okay, so you have to redraw it. Also, Li Qing, you have to draw the scale ruler at the side of the drawing. Okay, so let me show you the answer. Okay, so how to show this problem? How to show this problem? Yes. L equals 4 is equals to 6. Yes, I think Jianli, you are right. You are right. And Fatima, yes, Fatima, you are right. Okay, so let me see. So at first we have to draw the the 4 digging lines, and the elevation of the ground is 5 meters. And the bottom of this foundation is 1. The elevation is 1 meter. Is 1 meter. Is 1 meter. So the difference of this elevation of this surface, the two surface, is 4. You can see the 5 minus 1. It means use this ground. Use this elevation minus this one. Is 5 minus 1 is equals to 4. is equals to 4. And and I you can see I is equals to 1 to 1, 1 to 1, and the h is 4. Of course, L is 4. It's very easy. So at this side, the L is 4, and okay. And as for this one, with the same way, we can get L is equal to 6, and this one, L is equals to 6. And here the slope is not big as others. It is 1 to 2. So this one L is 4 times 2 is equal to 8. This L is 8. So please check your work. Sorry. And so the next problem, now we have already get the arrow at this 4 different directions. But how to draw the digging line? How to draw the digging line? So where can we get the arrow? The arrow. So you can see here is the scale ruler. You must use your scale ruler to measure the horizontal distance. For example, you can see here the arrow equals to 4. You have to use this distance, this one, use this one as the horizontal distance at the right side, and this one is 6. This one is 6. You have to draw the same distance like this in the upper and the bottom. And as for the left one, you can see the error is equals to 8, and you have to find the distance of 8 in the scale ruler, and then move it here. Here is 8. Here is 8. So now you can draw the lines that are vertical to the slope line, and this one, and this one, and this one. Okay, so that you can get the digging line like this, So let me see. Now we get the digging line. We got digging line, and it's finished. No. So just now Li Qing has forget the intersection line. It means that there is not one surface. There is 4 different surfaces, and they are not parallel to each other. They must have the intersection line. Okay. Here. Why we connect these points together? Because this point are the same, the contour lines with the same region is a cross point, and also this one, this line and this line have the same region. So we connect the cross point with the same region. So we can get the cross section line of two surface. Okay. So you can see that is the final. Result. I use the eraser. Also, there is details about how to represent the directions of the slope. So you can see here is 1. This elevation is 1, and this elevation is 5. If so, if there is no elevation, so you can't get the information about the slope direction from the top view. So if there is no elevation here like this, you can imagine it is like a shape like this one, Okay, so we have to to use this one, to use this symbol to represent the directions of the slope. Directions of this. It means that this point is higher than this one. The direction of the slope. The direction of slope. Okay, so let's have rest for 10 minutes. Let's have a rest for 10 minutes. And in the next part, we are going to do more exercise about the topographic drawings. Okay, so have rest. Please come back. Please come back at 11:10. 11:10. So it is not a regular. A regular rectangle is a irregular one. But it's not difficult. It's not difficult. Okay, so I think it's easy for you. Now, please follow me. So at first, you please see this question. The ground elevation of ground is -4, and the elevation of the bottom of this foundation is is -6, -6. So the slope of each plane is 2 to 1. It means 1 to 0.5, 1 to 0.5, 1 to 0.5. And now the difference of the elevation, is 2 meters. And the horizontal distance of the ground line to the foundation line to the foot line is 1. It means how to get 1? How to get 1 is 2 multiply 0.5 is equals to 1. Okay, so let me see. Yes, you are right, Li Qing. Maybe you read you draw it just now, or it's your homework? And so I will draw it quickly. And the you can see we get the horizontal distance of the two control line is 1. So this distance is 1. This distance is also 1 meters. 1 meter. 1 meter, and this one is also 1 meter. And this one is 1 meter. It's 1 meter. So because I don't have rulers, so I draw it. It's not very strict. And then connect the points. Connect the points. Okay. And finally, we have to draw this symbol to represent the directions of slope. It means that this plate. Oh, sorry, I draw wrong one. It's not this direction. It's this one. This direction. This one. Because this part is much higher. Is higher than the bottom. The ground is higher than bottom. So we have to draw the symbols from top to the bottom. From top to the bottom. Okay. So don't forget it. Don't forget. Okay, that's the answer of this question. Okay, so as for this one is your homework. It's your homework, and I don't do I need to repeat it again? So I think I have explained well. And so let's go on. If there is if the time is enough, so I will repeat it. And so next part, let's go on. So we have learned the slope of the plane, the slope of a plane. But how about the slope of a circular curve, of a circle plane, So as for for a cone, As for cone, you can see it's the cone is a object that with the same slope as each place in each place of the surface of a cone surface. Okay, so and as for this one, it's not the same. You can see this position. The slope is lower than this one. You can see this side is more steep, and this one is more gentle. Okay, so it's not a regular one. It's not a regular. And for this one, it is we convert, we rotate this cone, and we can get a shape like this, And as for this one, the how to say, the slope is all the same. It's all the same at each point. And then we are going to learn how to draw the circular surface, the circle surface, and the cross section line, the intersection line of plane and the circular plane and the circular plane. Okay, so as for this one, so you can see the ground elevation is 4, and the top of the dam is 8. It's a dam. So now we are going to draw the surface of the dam, the slope of the surface. We are given it's 1 to 1. Our part is 1 to 1, but here is not a plane. Here is not a plane. Here is a cone. Here's a cone surface. Here's a cone surface. So so it's easy for us to draw the plane. With a different contour lines. It's easy for us to draw. But how to draw this one? So it's the same as drawing the plane. So we also need to draw the contour lines with in a different elevation. They are parallel. You can see these lines are parallel to each other. They don't have the cross point. They don't have cross point, and so they have the same center point. They have the same center. So now at first we get the center, the center of the circle, and then draw the contour lines with the same elevation. Okay, and so for example, this one is 7, and this one is 6, and this one is 5. Okay, and this one is 4. And as for this one is 7, 6, 5, 4, and we connect the cross point. We connect the cross point that shaped with the same contour lines, cross with the same contour lines. In the same way, in the same elevation is here is 8. This one is 7, and this one is 6. This one is 5, and this one is 4. Okay, so we connect these points. So that is the the cross section. That is the intersection lines of the cone surface and the plane. Cone surface and the plane. Okay, so it's a big. The storm is coming. Okay, so you can see for this finger, the most important point is to find the cross point, let the contour line with the same elevation. You can see this line, this line's elevation is 7. This line's elevation is, and this one's elevation is also 7, and then this one is 6, and then this one is 6. So we get the cross point. We get towards cross point. The same. So with the same procedure, we can get the. You can see the 7. You can see this one is 6. This one is 5. And this 7, 6, and 5. And you can see this. We can get the cross point of the 5 of the contour lines in the elevation of 5. So this point, this one is 6. This one is 4. It's 4. And then we connect them together because you can because the intersection line is not a straight line. It's not a straight line. It is a curve. So we must draw more than 2 points. We must find more than 2 points. More than 2 points. If we only find 2 points and then connect it, you will get a straight line. But actually, it is not a straight line. It is not a straight line. Okay, so please remember. Please remember this. Okay, so as for the okay, so as for topographic drawing, I think it's okay. So please draw this one. This one. Okay. I'll do a review about this one. Okay, so please draw it again in your paper, in your exercise book. For 5 to 10 minutes. 5 to 10 minutes. So if you already draw it on your exercise book, so please draw it again in your exercise paper. So when you're drawing, please think about how to draw the plane, and how to draw the cone surface. How to draw a cone surface. The cone surface is several is combined with is consistent with the with several circular with several circle with the same center point. Same center point. So how about you? How about the drawing? Yes. Oh yes. Uh, and so I will repeat. I repeat how to draw it. How to draw it. So you can see the difference of every region is 3. Is 3, and the the slope is 1 to 1.5, 1 to 1.5, 1 to 1.5, and so you can see where is the contour lines with the elevation is 2. With 2 is to find distance as this one, and you have to draw here and draw a line like this. This distance is 1.5, and this elevation is 3, so this one is 2. This one is 2. Also, we need to draw a circular curve. Let the radius is bigger than the original one. The distance, this one is also 1.5. 1.5, and this is the contour line of 2, and then we will get the cross point. And then is 2, and then is 1, and then is 0. Also, for this side is 2, 1, 0. And we'll draw the circular curve, and this one. Okay, 2, 1, 0. And we get the cross point, or we got intersection like this. Okay, so that is a way to get the intersection line of the surface of a coin and a plane of a plane. So as for this kind of question, do you have any problem?
No, not sure.
No, okay. Okay, so let's go on. Let's go on, and I will show you another type. Can you do the second one? What's the second one? You mean this one? Okay, the second one is I think it's very simple because it is there are three planes. I'll find my. You can see this one is a plane. This one is a plane. It's also a plane, and the difference is the the slope are different. So I will draw it. So with same procedure, you at first find the difference of the elevation and then use the slope multiply the difference of the elevation, and because they are both plane, and not the surface of a cone. So we just draw only one contour lines on the same elevation. So you can see this difference is 3, and multiply 1.5 is equal to 4.5. Okay, and 4.5 is distance of this one, and I measured this distance and then put it here. I'll put it here, and then draw the draw the parallel line, and then of course this one is same. So it's 4.5, and this is 4.5. Okay, so I'll draw a contour lines. I can't use a ruler in the point, so so you can understand this. I hope you can understand. And for this one, this side slope is 1 to 1, and the difference is 3. The difference is 3, and I'll measure this distance. This distance here. Okay, and then I'll draw okay, and draw a contour line. So this is the result. This is result. Okay, can you understand? Can you understand this?
Is there intersection line?
Hello, what?
Is there intersection line this one?
Sorry, I can't hear it clearly. Is the
Is there intersection line this problem?
intersectional? Oh, I know this one. Yes, I forget this one. I forget. You mean this one?
Yes, Logi.
Yes, I forget. Yes, you have to edit this line. Edit this line. So maybe in your homework, these 2 point, these 3 point may be crossed at 1 point. So don't worry. You just connect this point to this one. To this point to this one. It's okay. It's okay. It is almost crossed at the same point, but not. It's because the slope is the setting of these questions is not very good. And as for this question, it won't appear in the final exam, because the figure, the slope, and the elevation is not very good. It's not very good. Maybe this one, or maybe this one and this one will appear in the final exam. Okay, so let's see another question. This one. Okay. Okay, so can you understand this question? Here is 2. There are 2 dams. Please draw the intersection line of each plane. So in the exercise book, you can see the scale ruler is 1 to the scale ruler is 1 to 500. 1 to 500. But usually we always use the scale ruler like this. This scale ruler means that when you use your ruler measure 1 centimeter, in the real space it is 500 centimeter. 500 centimeter. So it is scale ruler. Okay, so there's not much more time, and I will. Okay. Oh, sorry, I forget. Oh, so I have to always change the screen sharing. So I always forget. Okay, it's okay. So you can see there are two dams. Please draw the intersection line of each plane. And when and in this one, in your exercise book, you can see the radio, the scale ruler is 1 to 500, 1 to 500, and you can also use my scale ruler. Is given scale ruler, and you can also use this one. Because I can't use it is not a paper. It is not a paper, so I have to use use this one. You use the scale this kind of scale ruler to measure the distance. Okay, so let's go on. I will show you the result. How to draw it. For first step, please find the difference between 4 and 1. The difference is 3. The difference is 3. And slope is 1 to 3. So you can measure the distance is 3. Is 3 to 3 multiplied 3 is 9. Is 9. Okay, so this distance is 9. Is 3 times 3 equals to 9. Also, this place, this side is also 9. 9. Okay. And for this one is 1 to 2.5, and the difference is 2. 2 is 3 minus 1 is 2, and 2 multiply 2.5 is 5. It's 5. And now please measure 5 distance, 5 unit with scale ruler. I think maybe this one, maybe this one, and also this one. Okay, then I'll draw the parallel line. Parallel line. That this one is and then so the important part is to find the difference of this top and this top is 4 is 4 minus 3. 4 minus 3 and is equal to 1, and the slope is 1 to 3, and the distance is 3. Distance is 3. For example, this one is 3, and then draw a line. 3. And then prolong this part, then prolong this part, prolong this part. Okay, connect, connect. Okay, so now you can see the cross section. Delete it. Delete it. And then prolong this one. I'll prolong this one. And connect. Okay. Okay, so that is the drawing. That is the drawing. Maybe it's hard for you. Maybe it is hard for you. So I will explain it quickly. I explain it quickly. So now first you can see this top elevation is 4 and the ground is 1, and this small dam, this is a big dam, this is a big dam, and this is a small dam. You can see this small dam, the top of this dam is 3. The elevation is 3, and the slope is 1 to 2.5, and this one is the same. And you can see here the ground, the elevation of the ground is 1. Okay, so now we are going to find the intersection line of each plane. So now we have to check. So how many planes? At first, at the two sides of this small dime, there's two surface, two planes. And as for the big dam, there's a 1, 2. There's a 1, 2, and the important point, the most important point, is to find the the intersection line of this plane with this plane, and this plane with this one. So how to get these two line? These two line. Because the elevation of the big dam, the top of the elevation of big dam is 4, and the small dam is 3. And so we have to find the cross section, the line between this top surface, to this slope, Okay, so we have to draw a line. We have to draw a contour line with the elevation the same with this top. Okay, so the difference is 4 minus 3 is 1. Is 1, and the distance and the slope is also 3. So 1. You can use 1 multiply 3 equals to 3. Equals to 3. And now use the use the scale ruler to measure the distance 3. This one is 3. And no, Jianli, you are a small, you not do very well. So please look at me, because we have to prolong this line. We have to prolong this line. This point is given, but it's not the section point, the cross point of two same contour lines. So we have to find the same contour line with the elevation of 3. Okay, so I will draw this one. Okay. So now you can see this line's elevation is 3, and this line's elevation is also 3. So that we want to find the cross point, we must prolong this given line and get the cross point, and then connect this point to this point, and then connect to these 2 points. Of course, we have to also we have to prolong this side. We have to prolong this side. Okay, so this given one is not right. It's not right. We have to prolong it, and get the cross point with the same elevation, with the same with the 2 contours with the same elevation of 2 contours in the same elevation. Okay, so I think this is a hard point, is an important point, and it's not good. It's not easy for you to understand. Oh yes, you are right. Yes, you are right. And then please connect this line, this point. Connect this point. You can get the right answer. Okay. Okay, so today's is going to finish the class, and this class is the final class. Okay, so and I see that all of you have attended this class, so I'm very happy, and I'm very appreciate that you can support me. All of you can support me. For 12 weeks, so I'm very happy. I'm very happy, and get a very enjoyable time with all of you. The exact date of our final exam, I think you can ask teacher Peng. It's not dependent on me. Also I will ask for it. I will ask the teacher Peng. She will arrange the time of the final examination. Okay. So thank you very much. So I'm very happy, and I hope that I can see your lovely face in China. Okay. So I hope that when the COVID finished, so you can come to China. And we can I can see all of you. Okay. Yeah.
Okay, Lashi, thank you so much.
Okay, thank you so much. If you have any questions about the civil engineering, and whenever so you can ask me. You can send your problem to my email box, and you can send message. Also, you can send message to me. Okay. So thank you very much. Thank you very much. See you in the final exam. See you in the final exam. Okay, please prepare.
Okay.
Please prepare your exam. Hard. How to say? Please prepare your exam well.
هذا لا شيء.
As well as you can. Okay, I will try my best to give you a high score.
Okay, لا شيء. Thank you.
Okay, thank you.
Bye bye.
Bye bye. See you.
Bye bye, boss.
Bye bye.
Bye bye.